The next question we asked was, how much does speed and mass affect the force on objects during a collision? So we set up this launcher system where we launched a cart into a box. And then we started looking at the forces that were on the cart and then the forces that were on the box. And if you remember, we set up three different conditions, just called condition A, B, and C. In condition A, we had the cart go at normal speed and it was empty. In condition B, we doubled the mass of the cart, but kept the speed the same. In condition C, we doubled the speed, but kept the mass the same as it originally was. All the while, we were trying to see how it affected the force that the cart would have on this box, and we were able to measure that by how far the box moved. So here was condition A. The box was launched and moved about 10 centimeters, a little over 10 centimeters. Here's condition B, where they doubled the mass of the box by putting washers in, but kept the speed the same. And now you see the box went a little over 20 centimeters, so it got pushed twice as far. And then in the last one, condition C, now the mass is the original mass of the cart. It's empty again, but they're going to double the speed by pulling the launcher back further. And by doubling the speed, the box got pushed even further. It got pushed all the way just a little over 40 centimeters. So based on this information, we knew that because doubling the speed caused the box to get pushed more than doubling the mass, that speed has a greater impact or greater effect on force than mass does. And really what we're measuring isn't so much the force as it is the kinetic energy, because remember, when something moves, it has kinetic energy. So the fact that this box moved further when we doubled the speed means this box had more kinetic energy when we doubled the speed than we did when we doubled the mass, or more kinetic energy than it did, the box had more kinetic energy than it did at the very beginning in condition A. Then we decided to test a whole bunch of other situations with the cart and the box. So we used this simulation where we could change the mass and speed to whatever we wanted. We ran the cart into the box, we saw how far the box went, and then after collecting a bunch of data, we graphed that data. And here is an example of what our graph looked like when we kept the speed the exact same and just kept increasing the mass. We see that the box gets pushed further, which means the box has more kinetic energy. So as the mass of that cart increased, the kinetic energy on the box increased. And then with speed, we notice that it increases as well, but at a much greater rate. As we increased the speed and kept the mass exactly the same, the kinetic energy of the box increased at an even greater rate than when we were increasing the mass. So that led us to this on our progress tracker. Our question, remember, was how much does speed and mass affect the force on object during collision? And really we could change this to kinetic energy because that's what we were really measuring, is how much the box moved, how much kinetic energy it has. And our conclusion, the thing we figured out, was that as mass increases, the kinetic energy increases at the same rate. But as speed increases, the kinetic energy increases at an even greater rate or greater amount. The last thing we did was revisit our launcher system to try to figure out where the kinetic energy from the box came from. And we decided that energy just got transferred from one object to another. So when we pulled the launcher back, it had potential energy stored in the spring, and it got that from us. When we let the launcher go, then it transferred kinetic energy to the cart, which caused the cart to move. So now the cart, when it's moving, has kinetic energy. And then when the cart collides with the box, that kinetic energy in the cart then gets transferred to the box, causing the box to start moving. So energy just got transferred from us to the launcher, from the launcher to the cart, from the cart to the box. Because remember, energy cannot be created and cannot be destroyed. It can transfer, though, from one object to another object. Wow. That was a lot. Hopefully that's helpful. If you have any questions, I guess you could ask me or ask a different teacher. All right, see ya.